Now this is question number 4th, objective solved example, binomial theorem. Now, now before I start this question, in which we have to find remainder, remainder, if we have to find what will be the remainder if we divide 7 to the power 103 with 25, right? So I just want to briefly tell you how to solve these remainder type of questions based on binomial theorem. Using binomial theorem, how we can find a remainder in such questions. Now if you see the expansion of x plus 1 to the power n, nc0 x to the power n, nc1 x to the power n minus 1 goes on till the last term. Now if we divide this, if we divide this with x, right? See, then, and if you have to answer what is the remainder, then you can see from first term to second last term, all the terms has x as a factor, right? So this will be like the quotient, because every this part is divisible by x, this has a factor. Only this constant part has x is not involved here. This is not the multiple of x. So from this we find remainder. So remainder is 1 in this case. So like if let's see this question, 7 to the power 103. We have to find remainder when we divide this by 25. Now you can see the idea, from this we'll get the idea, from this we'll get the idea. We have to expand this as in terms of x, and this should be 1. If it had been 2 to the power x plus 2 or some other number, then it would have been a problem, because then all the last term would have been 2 to the power n here, right? Along with n will have x to the power 0, 2 to the power n, and because of that you can see we cannot say what will be the remainder when we divide by x, because of this 2 to the power n, because it is no more 1, right? So if you just follow that strategy, we have to express this base as 1 plus some multiple of 25, right? Because in this case it can be x, it can be x square, it would have been fine. So we have to think of writing 7 as this, fine. And how we can change this, we can bring down these powers to 7, right? So like let's check 7. Can we express 7 as 25 plus minus 1? No, we cannot. If you just go the next power of 7, 49. Can we express uh, 49 as 25 plus minus 1? Of course not. Then we increase this, instead of 25 we have multiple of 25. Multiple of 25, we can just write few multiples of 25: 25, 50, 75. Plus minus 1 is like 26, 24, 40, 9. Let's write the greater one here: 51, 49, 76, 74. Now we can see, just see this part, we have to see whether any power of 7 would match with this. So you can see 49, 49 is matching with this. So it means that we have to write this base, right? So it means that I'll show you. So we write it like this. We write 7 into 7 to the power 102, because we have to bring down 2. So we have to, this should be an even power. So we separate out 2, separate out 7. So make this an even power. And then we bring down 2. It becomes 49 to the power 51, right? We write this 102 as 2 into 51, because we have to bring down 2, like this. Now once we have this, just now we learned how to express 49. 49 we express 50 minus 1, multiple of 25. It should be multiple of 25 to the power 51. Now if we expand this in terms of like using x minus 1 to the power n expansion, 51 c1, 50 to the power 51, it goes on like this: 51 C1 50 to the power 50 goes on. Now the last term would be 51 C51 50 to the power 0, and this should be a minus 1 to the power 1. So you can see all these terms. If you just leave out the last term, 7 into all these terms starting from the first term, second term till the last second last term is 50 1c 50 50. Yeah, this is the second last term, and you can see all these terms are multiple of 25. Only this last term minus 7 is not the multiple of 25. Now from this we'll get the remainder. We add, because see, this can be, it should be a positive value, so we add 25 to this, and sorry, we subtract 18 and add 18, because we have to make this 25. We have to shift this inside the multiple of 25. And so you can see this becomes minus 25, again a multiple of 25 plus 18. So you can see from this whole part is multiple of 25 except this 18. So 18 is a remainder.